So I'm going to ask each of the panellists, we've heard from Andrew, but I am going to ask each of the panellists to make a short opening statement, and then we'll move to questions. So can I start with you, Leif?
Sure, thank you. So being a professor, I get to throw around big words. It's good fun.
Yeah, good.
Before we get into the policy side, I'd like to start with the idea of how big is all this data. So we hear petabytes and terabytes and so forth, per person, per second, per day. The world we're moving into doesn't bother with those numbers anymore. And I'll give you an example of one project within the world that I live in CSIRO, of the square kilometre array. So this is several hundred radio telescopes. Each telescope produces 10 times the internet traffic per second. Right? The whole of the internet, 10 times per second per radio. Now imagine the machine learning that is running on the top of that. And the point of that is that it won't matter how many zeros on the back of a petabyte I tell you about. The fact is that no human will ever be able to do that analytics. And so we've moved beyond the world of maybe I could debug the machine, and if only I put it all in a big box and got an IT department to look at it for long enough, I'd be right. That world of engineering is gone. And the world we are in now is the world where we simply have to admit that a good deal of our everyday life rests on a presumption of machine learning, machine use, AI, big data, buzzword here, as being necessary and sufficient to do our normal work. So I came from radio where we didn't bother doing proper circuit diagrams. We used the presumption that the software would design the circuit, and when we put the code on a GPU running in your phone, it would work, because we'd done the back-end work somewhere else, someone else, sometime else. And so I'm suppose what I'm moving towards is a world in which we have to simply admit that there probably isn't someone that you can ring up on a Sunday afternoon and ask if the machine can be fixed or if it's broken. Because we've gone beyond a world where there was one person who built that AI computer to a whole series of different people who are training different parts of those computers. We compose them together, and we're starting to look at the computer network as being more than infinitely scalable. The converse of this is we're now starting to work into the idea of saying, well, maybe we could use that network around policy itself. And so I will flip a little bit of some other work we're doing in Data 61, which is the concept that, so open question for you, hands up, who's read the Corporations Act? Nobody, lovely. You're all somewhere involved in a business, oh, one?
Yeah, I did.
Yeah, well done. Okay, so one person knows the acts that are covering their businesses that direct their payroll. Who's tried to explain it to a 7-year-old? Right? And you might say, well, that's a stupid thing to do. Who would do that? I was like, me. Why would you do that? Well, the public policy side of our argument misses a great step. And it was addressed a little bit in the sense of the previous speakers from the NDIS. If we're going to empower people to do their work, then we ought to at least allow them to know the legislations and policies upon which they're functioning. It'd be nice if we actually knew what that Corporations Act said. And so work around the idea of using the computer to empower those and to provide not merely better data and greater data to the back of the chatbot so the chatbot can tell you the answers and questions quicker and faster, which is a good thing. But more importantly, let's turn the whole of the regulation on its head so that rather than looking at this behemoth called government as a uniform and solid block, maybe what we could do is apply the same network concept per policy, per line, and then negotiate or modify or update or check against those regulations the same way we expect web pages and the rest of the digital world to operate. And so what I'm suggesting is essentially we need to accept that there is AI, that it is a necessary hammer that we will use. I try not to hit my hands with it. And we should apply that above and beyond merely better, faster, smarter data to better, faster, smarter life.
Wow, that's going to be a tough one. The concept of regulation as agile, I like that. Let me hand over to Tania.
to continue on from what Leif was saying, I see in the media a lot of fear around machine learning. So there's been recent articles in the paper about an American system that uses machine learning to predict whether someone should be given parole or not. And there's a lot of talk about, are those systems biased? And that's a fairly complex idea to unpack because these systems are trained on data. The data itself may have some bias from the previous systems that were in operation before the machine learning came in. So I feel that machine learning is here to stay, but there's still I work in a government agency, there's a lot of fear around machine learning, what it can do, and a lack of understanding about the risks associated with machine learning, and also a lack of understanding of, so in the agencies that I've worked in, there's been rule-based systems in operation before machine learning systems start to come in, and there's a lack of understanding. People think it's a rule-based system, I can understand that rule. There's a lack of understanding about the complexity that you actually get into once you have thousands of rules that have complex interactions. So one of my main points is that I think there needs to be more knowledge in AI and machine learning, particularly at the SES level and also with IT. So at immigration, when we brought in machine learning models, that was a very new thing for IT to manage. We were using R, which is an open source language, and there was a lot of fear around open source means, it's full of bugs and those kind of things. So one of my points is knowledge. I think there should be a job title that is machine learning educator. I hear people on the radio, their job title is a science educator. I'd like to be a machine learning educator. I have to say up front that when we talk about governance of AI and machine learning, my bias is I'm a data scientist in a government agency, so governance can be a bad word for me. But I'm in an intelligence agency. Austrac's job is to protect Australians from financial crime. Criminals don't have governance, as far as I'm aware, so there's always that tension between innovating to disrupt and prevent crime, but also managing the risk in line with community expectations. So Andrew mentioned you can jump online and download TensorFlow. In a government agency, you can't if you're a data scientist. You download TensorFlow onto your private laptop and you have a play with it. And then if you want to get it on a platform where you can actually run it against real data, you have to go through a whole long process. So I'm pretty sure criminals don't have to do that kind of thing. So that's where we need to become smarter about managing the risk of not doing anything or being too slow, as well as the risk of introducing new technologies. The other point I'd like to make, there's two more points. One is also about appropriate expectations of machine learning. So the hype cycle can be quite influential in this area, and it's quite difficult to, again, in a government agency, for people to see through the hype and to work out what are actual realistic expectations of the technology you're putting in. The final point I'd like to make, where am I up to? Is that processes, I think, are needed to manage the risk of these new technologies. So within the data science field, there's lots of processes built in around best practices to manage risk. And it's about developing that expertise and maturity in data science to appropriately manage risks.
Thank you, Tania. I think the points that you raised there, we'll come back and explore a little bit more, but actually get to the crux of why we are having the day that we are having here today. If we think about the role of government and the digital transformation that we're all seeking, there are two aspects here. There's government as the policymaker, which is a task that we expect government to take in an informed way and in consultation with industry. But there's also government as the business of government. And government represents something like 1/3 of the technology spend in every Western democracy, including Australia. And as such a consumer and user of technology, we expect the government to operate efficiently and as an exemplar. And I think that's one of the real opportunities in front of us. So I'd love us to be able to explore that further. Andrew, given Leif and Tania's comments, is there anything you'd like to add, or shall we roll straight into questions?
No, just look, I completely agree with them. I think, the reality is that the term artificial intelligence, be it machine learning, whatever it is, I don't necessarily think that it's here to replace our jobs, to replace our roles in society. We seem to have this opinion of it in the media and general consumers on a day-to-day basis through Hollywood, and it couldn't be further from the truth, I think.
Okay, thank you. So we have some time for questions now. Does anyone have a question straight out of the blocks? Right down front, Rob.
Rob Miller from Collaborate. It's not only the press that have raised questions about the risks associated with artificial intelligence. People as prominent as Dr. Stephen Hawking started raising this issue back in 2014. To avoid running the risk of the artificial intelligence argument becoming almost like the climate change argument, do the scientists involved have a responsibility in educating policymakers on not only the benefits but the risks to society associated with this?
So, yes. Look, simple answer, yes. Right? Let me go on. So, and the reality is, if I was selling swords for the point of cutting up onions, that'd be a nice thing to do, but we'd all know that really wouldn't be a very viable or sensible business model. So there are a number of people, so Stephen Hawking's one, Toby Walsh working within our group, there are a number of people in the AI world looking at what I would say is a great deal of blurring. And the world of the chatbot is one where it's happening, where we are personifying AI. So we are referring to the machine that does a lot of work, and it's great, but we're naming it. And the example I'll give you is an anecdote is I had a chat with a person who was setting up a meeting, and he CC'd his EA, and his EA was a chatbot. Great. So then, unfortunately, one of our other people started having an interaction with that chatbot, unbeknownst. And we all go, ah! Well, how would you know? On the back of an email, you don't know that other thing is actually not human. And so there's a great deal of difficulty that we have to not just say that's a bit mean, but rather we have to educate the whole population in the same way we presume that everybody has maths, a level of English in reading, a level of science understanding. We have to start educating people that these things are not just on the never never, and if you watch Dr. Strangelove or an appropriately sci-fi movie, it might happen out there. This is actually real. And to the extent we need to explain, both to the tool makers, right? Be nice if you put a handle on that knife. Be nice if you put a warning sign on the back of it. But it's more important than that. We have to educate the population beyond fear, uncertainty, doubt. What do these things look like? How does interacting with them work? When you're using machine learning, it's not some crazy bubble in the back of the box. It's actually running on your phone, explaining when your calendar might be updated. And so it makes the experience understandable and real. And so we have a conversation about what to do with this thing, not, oh, the bomb is going to kill us all, or, oh, the machine is going to eat my job and my kids, right? We are having a conversation about what to do with this technology, knowing that it is both good and bad, depending upon how it is used.
Can I just add to that? You know, if there was one outcome that I could get out of today, I think machine learning educator is exactly. I think that's what's needed. You know, you listen to the radio. You know, you speak to students in high school. You say, you know, what did you learn? Well, an educator comes in. It teaches them. You know, we need to educate society, but we also have a responsibility to educate government, and government likewise has that responsibility to educate society back on what the impacts are going to be around machine learning and on all of us. But yeah, my vote, I've got it. So.
Thank you. Yes.
Chris Johnson from the Council of Deans of ICT. concerned with the other side of education, that is educating the technologists. Should we be doing that better to train new students in not just techniques of AI and machine learning? What else do we need to teach them? Or should we have a policy of not teaching them dangerous technologies until they get to some safer place where we can have some more responsible education?
Well, I'm going to answer that first, but I'm just going to say I don't think it's a dangerous technology, because anything can be dangerous. You know, you can drop a phone off of a building and, you know, kill somebody below, but we don't ban phones on roofs or anything like that. You know, we don't ban cars, even though we know that the most dangerous thing inside a vehicle is the human being. You know, the vast majority of car accidents we still know are at human error, but we don't ban humans from driving cars. So the technology is not dangerous, I would just say to that, but I'm going to pass it off to let somebody else answer the rest around education.
So definitely there needs to be more opportunities for education in this area. So I've worked in the sector and the data science courses that are available are very new. So it's only in the last couple of years. So ANU has a data science course that's available at postgrad level. And there's a few other regional universities in Melbourne. But it's a very new field, and as always, universities tend to lag behind a little bit. Definitely what I learnt in a master's at university was a little bit behind what was happening in industry. And that's a conversation for universities to have with industry, and to start to bring in more industry expertise rather than insisting everyone has a PhD and has come through academia to teach.
Agree. And I would add, just to say yes, and in order to the question, should we wait? No. And so I did engineering a long time ago, and the third year of the standard engineering course back then had people doing a philosophy degree, a discussion on society, and something to do with business. And you can see that I took all of those very seriously as an engineer. I would say sticking it on the side because, hey, we should really cover ourselves off on the don't hurt people, but get back to work. Right? That we need to start very much earlier and ask, rather than how do I teach people not to hurt people, because I think most people understand that, rather ask why. Why am I building this thing? What is it supposed to be doing? What could it do? And in a sense, it's not a question of, well, if I build this autonomous vehicle, will it crash and kill somebody? That's way out there in the extreme. It's, do I build something that replaces the job of my next door neighbor? And if so, why? Now, it may be for a very good reason. Maybe my next door neighbor does something else, right? I don't think many of us are out in the fields cutting wheat anymore. Very few of us work in the looms of the old gin mills. We do other things now. But we ought to ask why before the machinery pops up, and then we ask, oh, now what?
Yeah, and can I just add to that? You know, one of the you mentioned earlier about this open AI with Stephen Hawking, and I think it's Bill Gates and Elon Musk that have founded this. I think that's more the point. Is, you know, you have to have that conversation about it, not and ask the questions about, you know, what's the potential of it, etc. Rather than just setting up a boundary and saying we won't even talk about this topic. And that's one of the things that I think has been misconstrued about the concept of that open AI, and, you know, the whole talk about that isn't necessarily that they're looking to say, oh, this stuff's scary, let's be fearful of it. They're trying to say, let's approach it in a way that is an open community discussion. Exactly what we're doing here, but they've given it a brand effectively. And I think that's what we need to do in Australia, because other countries around Asia, I see, are doing that today.
Okay, thank you.
Use experience to change the way that we deliver and so forth. I just wanted to ask the panel, what's the exposure to government, both elected and within the public service, of analysing the data that we have on our legislations, on our policy, using that data to train and understand, you know, the deficiencies or the areas that are going well with that legislation? Because obviously, you know, as you can see with the law profession, it's a very detailed scenario with lots of data that can be analysed via court systems, via just legislations around the world. Are you seeing any of that and how that's impacting the policy?
Any
I'll
takers?
start.
Yeah.
So question back at you, audience. Anybody know what the biggest source of data that government creates? Not government forces others to create, but government itself creates.
Hot air.
Policy. Right? The written material that we like to refer to as legislation, regulations, policies, guidance documents, that's the data that government creates. Everything else government asks somebody to do, or it forces them to do, or it collects it for them. But in a sense, so in answer to the question, we have started looking at the idea that policy and regulation and legislation is just data. And when you take that shift and go, oh, it's just data, it's text data, but it's data, then you do all the usual things you do with data. You say, what am I doing with this stuff? How much of it do I use? Is there a bunch of things that don't work with other things? Once you take the mind shift, the application of the usual suspects from data science just drop out. Now, the uptake in government at the moment is smaller because there's a big difficulty in saying, well, could I write code and call it legislation? What would that mean? What would happen? What would happen to all the people and all the indoor? So that's slower, but in a sense, we're working on this concept, and we've been calling it regulation as a platform, right? But it's bigger than one organization, and there is a growing area of understanding both nationally here in Australia and across the world that if you treated legislation in the same way you treated the average data entries that we deal with, then you'd probably get an awful lot of benefit because you'd be able to measure at a legislative layer, at the person, at the business, at the compliance, and you'd be able to hook all the dots together and actually do something remarkably useful, rather than merely saying, this is the way I want you to behave, now hire a lawyer.
Leif,
I'll just add to that
Yeah.
that AUSTRAC has done a pilot with Data61 to run their legislation through the tool to change the legislation into basically logic, and that has been really helpful in understanding the how bits of the legislation impact other bits, so that the flow of interactions between different aspects of legislation.
So to try and bring this back to, thanks for bringing the conversation back to agile regulation and the policy domain. Leif, if you can digitise policy and to the whole panel, can you then move to creating an algorithm that's an X minus Y, where you're taking the perhaps static regulation and the dynamic nature of the economy in all sectors of the economy, and start to identify and then predict where dynamic changes in the economy are going to bump up against the hard wall of regulation? We're all given the example of Uber around the world. There is a great platform example which was testing policymakers and regulators and legislators about what the policy environment would be. We're taught it around digital identity, where there are issues that we are bumping up into regulatory barriers left, right and centre, and some of them are fantastic barriers. They're there for our own safety around managing risk, etc. But is there a way that that technology can help us understand where regulation could be getting ahead of the curve and enabling and perhaps fostering new innovation and new creativity?
So the answer is yes, and that's sort of why we're doing this. Isn't sort of the naive approach would be say, gee whiz, if only we made all this stuff digital, it would be so much better. Right? But my view is that would be doing dumb things faster. Right? And computers are great for doing dumb things fast, but if we considered regulation born digital, it isn't a PDF document on the web. It's a piece of code that hooks into the usual business. And so what's possible is actually moving away from a government agency, whatever that might be, doing its job and having the job trickle down to the hoi polloi, but rather acting as concierge. If you're hooked into the back of the business, then the business is compliant automatically. If you're asking a question, could I do this? Well, the legislation isn't there and it's digital. And you ask the question and the legislation says, yeah, that'll work. So it's no longer a question of how do I understand 70 different pieces of legislation to start a business, because that's what it takes. You're asking, what do I need to do tomorrow? And the shift is actually saying the government sits to make sure the policy's right, and the regulators make sure it's enforced, but they don't have to call you up on June 30 to check whether or not you're swimming between the flags. In fact, that's just done as part of the normal business process, as part of the normal societal process, because the digitization is making it part of the normal digital process that we already live.
Thank you. Tania, Andrew, any experience from China, from Zhegu?
Yeah, so you know, one of the things that I guess they've seen that they've been doing there, and as well, one of the things that we've been doing with US states is around policy negotiation. So algorithms that'll help legislators to better negotiate policy through Senate, etc. They actually started using, I can't remember the name, there was a system that won one of the AI competitions in poker. And so they used that same poker system that the university, because what's poker? It's about reasoning and you know, effectively bluffing. And so they were using the same algorithm. And so they started to use this within the state. And it was highly successful because they worked out that it could anticipate what the other senators would actually come up against. So it's happening today.
Thank you. The concept of poker and politics going together. Tania, any final comments?
I'd just add, it's slightly off topic, but so AUSTRAC's investigating regulation as a platform. Part of the role of AUSTRAC is for the banks to send us specific data that comes under our legislation. And we're exploring the idea of a platform where, as long as the bank is on that platform, we know, so code executes so that we get the correct data. Therefore, we're not being a regulator with a stick saying, make sure you're doing the right thing, but we're actually encoding that into the platform that people are using.
Fantastic. Well, thank you.
Thanks.